All right, people, it's our last review before your test, so making a video, posting it for those people that want to do a little studying tonight before your test, so hopefully it helps you out. You should have one of these calculators out next to you when you're taking the test, and you should have a writing utensil. So I'm going to use both in the review. You should use it in the test. So make sure you are using it. If you are not using a calculator, you're not doing the test right. So make sure you have one by your side. Okay, so with that said, number one, it said evaluate each of the following at n equals 2. So that just means that we're going to take the 2 and we're going to substitute it in for the n of each of these different functions and get our answers out. Okay, so our first one. We want our calculator to look exactly like what is in our function. So it should be -5 to the second power, and it's 2 because it is n equals 2, and hit enter. And we get -25, and that is because this is really -1 times 5 times 5. All right, the second one, we're going to change it a little bit. It looks the same, but it's not the same answer. So make sure that you make your calculator look exactly like what the problem is with the parentheses, so that the negative is repeated. When it's inside the parentheses, that negative is actually repeated. So this is -5 times -5, which is 25. And then our last one, it is -10. So this one's a little more straightforward. It's -5 times 2, which is -10. So don't really need the calculator for that one. And you don't need the calculator for the other ones if you understand how the math works. So anyway, next one. Find the next 3 terms in the sequence. Identify the operation used. Identify the operation used to generate the pattern. Okay, so this one we are 3, 7, 11, 15. So it looks like it's adding 4 each time. So it's adding 4 each time. And this is what you would call like common difference. Okay, and the next 3 sequences would be 19, 23, and 27. So we're adding 4 each time. So 15 plus 4 is 19, 19 plus 4 is 23, 23 plus 4 is 27. All right, the next one, it looks like it's decreasing, and it's decreasing rapidly, which really probably indicates that it's a geometric sequence. If you're not sure how to figure out what it's decreasing by, you can take the second term and divided by the first term. So grab our calculator and say 512 divided by 4096, and we get 0.125. Okay, and so we should have, let's just double check here to make sure we get 0.125. We can do the third one divided by the second one, the third one divided by the second one, and we get 64 divided by 512. And you get 0.125. All right, so this is a geometric sequence. So what we need to do is take our last number here and get the next 3. And so we're going to multiply 8 times 0.125. And you get 1. And then you're going to take 1 times 0.125. And you get 0.125. Anything times 1 is itself. And then 0.125 times 0.125. And we get 0.015. Actually, it's 1/6, so we're rounding. Okay, so make sure you round that correctly. Go to the fourth one. If it's higher than 5, that number goes up. Okay, our next one. Given the geometric sequence, -7, 14, -28, and 56, find the common ratio and then find the next 3 terms. So that's really similar to what we just did up here. So the common ratio, you would take the second term, so 14, and divide it by the first one, -7, and you get -2. So our common ratio, or R, is -2. And to find the next 3 terms, you would say 56 times -2, and you get -112. And then -112 times -2, and you get +224. And then you get +224 times -2, and you get -448. So we're just multiplying the whatever the last term by our common ratio to get the next one. Okay, that's actually leading into the recursive rule, but it's not actually, you're not writing out the recursive rule, but you are actually in fact using it. Okay, so our next one, number 4. Matt's bank balance forms a geometric sequence. What do you know? At the end of the first month, he had $800. At the end of the second month, he had $1,200. And at the end of the third month, he had $1,800. What is the balance at the end of the 5th month? Well, the first thing you need to know is R. And to find R, you divide the second term, 1,200, by the first term, 800. So we're going to do that, and we're going to 1,200 divided by 800, and you get 1.5. Holy smokes, this bank is paying some money. Okay, so we get 1.5 is our common ratio. So to find the 5th term, we're going to take our third term. So if we make a little table here, we know that, so if this is n and this is f of n, we know that 1, 2, 3, we know 1, 2, and 3. Okay, so 1 is 800, 2 is 1,200, 3 is 1,800, okay? And so to find 4, you're going to multiply 1,800 times 1.5. So you got 2,700, okay? And then 2,700 times 1.5, and you get 4,050. Okay, so our 5th term is 4,050. So because this is a word problem though, I'm looking for a sentence answer, and you should say something like, the bank balance is $4,050 at the end of 5 months. Okay? Okay, so just to let you know, you do not have to do this table. This table is just a helper. If you can multiply 1.5 times 1,800 and then times 1.5 again to get to your 5th term, and you see that, you don't have to write this table. But for those of you that are not seeing what I'm doing as far as getting to the 5th term, when you just see like, hey, oh, it's 1.5 and the answer is 4,050, I'm doing this. So if you need this to help you out, do this on the test, okay? All right, next one we have use the given information to decide the equation. Which equation will be easiest to use to find the indicated value? Find the value and explain your choice. Okay, the value of the 4th term is 80. The sequence is multiplied by 4 at each step. So your common ratio is 4. All right, so find the 5th value. Well, if you know the 4th value, you can take that 4th value of 80 and multiply it by 4 to get the 5th value, right? So you have 80 times 4. And you get 320. Okay, but what happens when I'm not asking you for what the next term, what I'm asking for the 10th term? So in this case, you're gonna wanna use the recursive rule, which is this guy right here. So you're gonna take, I'm gonna do it above it a little bit so we have some room to work. So we have 1.25 times 4, and we're gonna say 10 minus 1 here, because n is 10, and we still want that -1 in there. So 10 minus 1 is 9. So we can substitute this into our calculator and go 1.25 times 4 to the 9th. And we get a really big number, 327,680. Okay? All right, next one. We have f of n is 192, so we're looking for the 192. What is the value of n? Well, if f of n is 192, that makes n 4. So what is the value of f of n minus 1, which is 48? Okay, so find the f of n is 12, so value of n is 2. So now we want to go up 1, which is 48. f of n is 768, and we want to go down 4. So 1, 2, 3, wait, sorry. 1, 2, 3, 4, and we get 3. There we go. All right. Now we're getting into the recursive and the explicit rules. Okay, so write the recursive rule and explicit rule for each of the geometric sequence. Okay, so the recursive rule is pretty straightforward. You need f of n equals f of n minus 1. So far, this is exactly the way it should look on your test. No different. You could copy that straightforward. Now you need to figure out what goes here, which is the common ratio. So common ratio, you take the first term, or the second term, and you divide it by the first term. 24 divided by 6 is 4. So you put 4 right here. Okay? The explicit rule is a little different. You're going to say f of n equals our first term, 6 times our common ratio to the n. Okay, but if n is 1 here, that's 4 to the first power, okay, which is 4. 6 times 4 is 24. That would mean that it would be really 2. So we need to back it up 1. That's why we put it n minus 1. So if you didn't understand that explanation, if you're writing it this way and you're using the first term here and you're using the common ratio, you need to include that n minus 1. Okay? So your first term, your common ratio, n minus 1. Flip it over. Okay. So the exponential, is it an exponential equation? So we have, or an exponential function. This is an exponential function because it's got x as an exponent. This is not an exponential function. Even though it has an exponent in it, the x or the input is not the exponent, all right? Okay, consider the sequence. Okay, select all that apply. The common ratio is 1/4. Well, if you are not sure how to find the common ratio with this one, remember you don't have to use the fractions here to find the common ratio. You can go where the whole numbers are whole. You can say 4, or you can say 4 divided by 1 is 4. So your common ratio is 4. So the common ratio is 1/4. That is not true. The common ratio is 4. Well, yeah, we just found it was 4. The seventh term is 1,024. Okay, so we have 1, 2, 3, 4, 5. So 6, 7. So we can do 16 times 4, and then times 4 to get 2 more, and we get 256. So let's just double check that. 1, 2, 3, 4, 5. So 16 times 4, that's 64. And then times 64. Oops, sorry. 16 times 4 times 4. And you get 256. So we got 1, 2, 3, 4, 5, 6, 7. Nope. The 10th term is 64 times the 7th term. Okay, so we have 7, so we need 3 more. So we need 256 times 4, which is 8, times 4, which is 9, times 4, which is 10. So 10, the 10th term, is 16,384. Okay? Okay, so the 10th term is 16,384. We need to know if the 64 times the 7th term will work for that. Well, our 7th term is 1, 2, 3, 4, 5, 6, 7. So 256 times 64, and we get 16,384, and that is true. All right, the first term is greater than the second term. Nope, not true. 1/4 is much bigger than 1/16. The sixth term is 64, so 1, 2, 3, 4, 5, 6. That is true. All right, going down here. A, let me zoom out a little bit, make sure I get everything. Okay, complete the blanks for the function. It goes A and B, so that's your first kind of easy step there. 2 and 5. Well, you got a couple points. Now you need to find the y-intercept. Well, y-intercept always starts with x is 0, so this is 0, 2. The asymptote, well, that's kind of where this is never going to touch. It's approaching y equals 0. The domain is all real numbers. And the range is y is greater than 0. And we know that it has to be greater than 0 because 0 is where it's never going to touch. So it has to be bigger than that. All right. Next up. So this is where the calculator really starts coming in handy. Okay, so I've got a formula here, 1 divided by 2. That's that 1 divided by 2. And we're going to have our parentheses of 4 to the negative 1. And we get 0.125. So then we change our number up here, go back to that same equation. We can delete those guys and put 0 in there, and we get 0.5, which is also our y-intercept, 0.5. So our next one, we're going to go up here, we're going to change that 0 to 1, and we get 2. Okay, so we're going to go back up, and we're going to change it to 2, and we get 8. Then we're going to change it to 3, and we get 32. Okay, so you're going to now graph these guys. So it's negative 1 and then 0.125. So really small, really close to that line. And then we have 0 and 0.5. So it's halfway up here. And then we have 1 and 2. Then we have 2 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then we have 3 and 32. And that's way up here, right? It's way off the graph. You do not connect these. I gave you the x values, so it's discrete. Discrete meaning like it's not connected. It is only these points. I give you the x values. That one's done. Okay, last but not least. Video is getting long, but it is your review for your test, so I don't want to leave anything out. Okay, you'll notice how I do not give you x values to start with. Well, you can pick any x values that you want. I recommend picking something that you've seen on the test already, okay? Okay, you'll notice that I just took these values from what we had on the last problem, and now you can start entering in your equation. Okay, so this one is a little bit trickier, but I believe you can do it. Okay, so we have 2, and I'm gonna have you start doing a little math in your head, and that little math is going to be substituting the x in here. So we got negative 1 minus 1. So this is 2 to the negative 2. Okay. And that's 0.25 plus 1. So that little last plus 1 here. Okay. So this one's a little bit harder to like resubstitute your numbers in. Okay. So you're going to have to do it a couple more times. There is a way to do it, but I think it's going to be easier doing it this way. I can show you the other way to do it once we get to the test, before we get to the test tomorrow, if you really want, like if you're dying to see it. Okay, the next one, you have 0. So we can still go up and we can use that previous equation if we want. And so we have 0. And 0 minus 1 is negative 1. And we get 0.5 plus 1 is 1.5. Okay, so our next one is going to be 1. 1 minus 1 is 0. 2 to the 0 is 1. So if you're not sure how to do that, we can substitute 0 in here. And we get 1. So 1 plus 1 is 2. Okay, so 2, substitute 2 in for x. And you get 2 minus 1 is 1. Plus 1. And you get 3. And the last one, you're going to have 3 minus 1 is 2, so we're going to change that to 2. We get 4 plus 1 is 5. Okay, so we have negative 1 and then 1.25. We've got 0 and 1.5. We've got 1 and 2. We've got 2 and 3. And we've got 3 and 5. Okay, so you can see it start curving. This is not a discrete graph, it's continuous. And this one, it's kind of cool. The asymptote is shifted up 1 because of that positive 1. Okay, shifts up 1. So our asymptote is actually now y equals 1. Our y-intercept is 0, 1.5. Our domain is all real numbers. And our range is now y is greater than 1 because our asymptote is 1. It's never going to cross it. Okay, so good luck on your guys' test tomorrow. Hope you review it tonight.